You're at a restaurant. You sit down, glance at the menu, and tell the waiter, "I'd like a cheeseburger, fries, and a soda." You don't march into the kitchen, chop onions, or flip burgers yourself. The waiter takes your order, translates it into something the kitchen understands, and, like magic, your meal appears. Building modern software is a lot like that restaurant experience. Developers want to work with objects, like a movie or a user, while the database only understands tables, rows, and columns. How do we bridge this gap so everyone gets what they want, without chaos in the kitchen or confusion at the table? Welcome to the world of Object-Relational Mapping, or ORM for short. Let's break it down. In programming, we love objects. They have properties and behaviors, like a movie with a title, year, and cast. But databases? They're all about tables, columns, and rows. This difference is called the Object-Relational Impedance Mismatch. A fancy way of saying, hey, these two systems speak different languages. So, what does ORM do? Think of it as our waiter. It translates your object-oriented requests into something the database understands, and vice versa. You want to save a new movie? Just create a movie object and call save. The ORM handles the SQL, the table, the columns, all the kitchen details you'd rather not deal with. How does ORM actually work? Let's say you're building a movie app. You define a movie class in your code. ORM frameworks map this class to a movies table in your database. The class's properties, like title and year, become table columns. Relationships, like a movie's cast, are mapped too, so you can easily fetch all actors in a film without writing complex SQL. ORMs handle all the create, read, update, and delete operations for you. The ORM translates these actions into SQL behind the scenes, so you can focus on your app, not your database syntax. Let's look at how Django ORM, one of the most popular ORMs for Python, works in practice. Here's how you might define a simple book model. Let me walk you through this code. We're importing Django's models module, which provides the building blocks for defining database tables. Then we create a book class that inherits from models.model, which tells Django this class represents a database table. Each attribute defines a column in our table. Title is a character field with a maximum length of 200 characters. Author is a foreign key that links to another table called author, with cascade deletion, meaning if an author is deleted, all their books are deleted too. Published date stores the date the book was published, and price is a decimal field that can store numbers with up to 6 digits total, 2 of which are after the decimal point. In the first line, we retrieve all books from the database. Behind the scenes, Django creates a SQL query that says, select all from books. In the second line, we use Django's special syntax. Price $LT equals 10 means price less than 10. Django translates that into a SQL query with where price is less than 10. The third line looks up a single book by its title. This gets turned into a where title equals something. SQL condition. Notice, we never write any actual SQL. We just use Python methods and objects, and Django takes care of the rest. Behind the scenes, Django translates these Python expressions into SQL queries, executes them, and returns the results as Python objects. Developers are big fans of ORMs because they make life easier. Instead of drowning in repetitive SQL, you can focus on building actual features. More coding, less copy-pasting. They also make your app more flexible. Switching databases becomes way less painful since your code isn't tied to one specific flavor. Plus, security gets a boost. ORMs automatically handle queries in a safe way, reducing the risk of sneaky SQL injection attacks. And with your business logic cleanly separated from data access, the whole codebase becomes easier to read and maintain. But hold up, ORMs aren't magic. Imagine you're at a restaurant and the waiter brings each item one by one or keeps messing up your order. That's kind of what can happen with ORMs if you're not careful. They can introduce performance issues, like generating inefficient queries that slow things down. The dreaded N+1 problem is a classic. Instead of one efficient query, the ORM fires off a bunch of tiny ones. And if you're after tight control or blazing performance, ORMs might feel like they're getting in the way. Rely on them too much, and you risk forgetting how to write solid SQL when it really counts. To get the best out of ORMs, think before you model. Keep things clean and focused. Don't turn your data layer into a mess. Be smart about what you fetch. Only grab what you need, not the entire buffet. Use eager loading to dodge the n+1 problem, and remember it's totally fine to drop down to raw SQL when needed. Keep your database transactions quick and efficient, and you'll strike the right balance between convenience and performance. So, should you use an ORM? If your app is all about creating, reading, updating, and deleting data, and you want to move fast, ORMs are a great choice. But for complex, performance-critical systems, sometimes you need to roll up your sleeves and write SQL yourself. So, here's a question to ponder. If ORMs make our lives so much easier, what might the next big leap in database interaction look like? Will we ever need to peek into the kitchen again? Or will the waiters of tomorrow handle everything for us, even before we know what we want? If you enjoyed this, subscribe for more and turn on notifications to stay updated. Found it helpful? Like, share, and drop your thoughts in the comments. Thanks for watching. See you in the next one. Have a great week.